In this lesson, we will talk about interfaces with Java. Interfaces specify a common behavior for a set of classes. Interfaces that you might already be familiar with, that you'll probably see later on, are things such as objects being comparable or clonable, etc. But we will kind of use the cooked up example for the purposes of this lesson to understand interfaces. So we're introducing a new keyword called interface to use instead of using the keyword class, right? So an interface, when it's defined, takes the following form. It's interface, the keyword followed by the name of the interface. Now within the body of the interface are any number of constant or static variables and any number of abstract method declaration that need to be completed by the actual class that implements the interface, and we'll talk about that in a bit. So let's take a kind of a concrete example, though a cooked up one. So let's say we have an interface called mammalian, right, and which is the behavior that all mammals do, so such as eating or traveling, and these are abstract methods. They don't have a body. They're basically declarations here, right? So by default, interfaces are public and abstract, and the data fields are public and static. So the above is the same. It can be written more concisely as this, leaving out public and abstract, right? Okay. Now, interfaces, when you are dealing within programs, are treated like a special class. They're compiled into their own .class file, right? Just like an abstract class, you cannot create an instance of an interface using the new operator, right? But you can use in the interface as a data type, right? That's perfectly fine. So, for example, you can use mammalian interface to specify an object of that is a mammal, right? The additional keyword that we use for using interface is implements, right? We use the implements keyword to say that a class implements the interface. That means it provides the definition to the abstract methods that the interface has, right? So continuing our kind of cooked up example, an elephant class and a human class could implement the mammalian interface to specify that elephants and humans behave as mammals, right? So when a class implements this interface, it implements all the methods defined in the interface, all the methods that were declared as abstract in the interface, right? Else, if it doesn't, then it becomes an abstract class, right? So either it implements all the interfaces, completing the method definitions, or it itself must be left as an abstract class, right? So this implementing of an interface is also sometimes called interface inheritance, right? It's very similar to class inheritance. So let's continue our concocted example and then see what this might look like in code. So as I had said, you could have a class elephant and a class human implement an interface, which is mammalian, right? And if it does that, it must provide the definition for eat and travel, which were the two methods that were abstract in the interface, right? Additionally, it could define its own methods, like number of legs, that is not part of the mammalian interface, and give that definition, right? So, okay. So the very next natural question is, well, how do interfaces and abstract classes that we recently learned about in another lesson, how do they mix and how do they work together? So let's take an example of what that might look like, right? So let's say we have an abstract class called organism, right? And it's abstract because it has an abstract method called sound that the organism, makes. Now, the elephant class and the human class would extend organism, but implement mammalian, right? So there's extends and implements are the two keywords that are being used together here, right? And so in this case, besides giving the definitions of the other things in the interface, they are implementing sound in each case, because that is something that the abstract class requires. Okay. Now, interface inheritance works a little bit differently than class inheritance. A class can only extend from one superclass, right? Multiple inheritance for classes is not allowed. However, a class can implement multiple interfaces, right? So it's single inheritance for classes, but multiple inheritance for interfaces, right? So let's take a look at what that would look like in code, right? So we might have an additional interface, matriarchal, that would provide another method to implement, right? And the elephant class could extend organism but implement multiple interfaces as shown here, and then provide the definition for other methods that the additional interface provides, right? So multiple inheritance or interfaces is allowed, right? Okay, the next thing we have to address is, okay, all this, how is it represented in UML, right? So the stuff we were talking about earlier is how it shows up here. Notice the way interface here is represented with the carets signs here. Also, the name of the interface is in italics, just like it is for abstract classes, right? Organism here is an abstract class, so that's why it's in italic. The methods are also in italics, but they are also abstract. The other thing to notice is that whereas in class inheritance and in inheriting from abstract classes is represented with a solid arrow going back to the abstract superclass, here implementing interfaces is represented with a dashed arrow. Okay. The next order of business is to learn about this new operator called instanceOf. The instanceOf operator can be used to test whether an object is an instance of a specified type. So it could be a class or a subclass or an interface. It returns either true or false. It's a binary operator, so it shows up in the middle of two things. So let's look at some code of what that might look like. So what we have here is a program, and in the main method, we are creating an object with a constructor for human. Now, it might be useful to have this UML here handy above, right? So this is what we're doing. And all the code above, we were representing this UML diagram. So we can take this object and test it for various things. For example, we can say, is this object that we just created instance of matriarchal? And if you examine this, and you'll notice that there's no arrow going from human to this interface, right? So this is false, right? And if you test it with mammalian, there is an arrow. It does implement this interface, so that is true. Is it an instance of organism? Organism was this abstract class, right, that we extended, and so that is true as well. Is it an instance of elephant? Now, elephant was another subclass of organism. There's no arrow going, there's no relationship here. Then is it an instance of human? Now, it itself is of type human, so that obviously is true. Okay. So what we can use this for is in code to check things for availability of certain methods. For example, you can say, hey, is object an instance of this interface, which provides certain methods that are available, right? So you can test it and then safely go ahead and use this, right? Okay. Now, just like with the lesson covering abstract classes, this can get confusing with all the relationships and abstract and public and all the various modifiers. So let's try an exercise where we look at different declarations for an interface called A. And we'll see whether those are legal, right? So to try that out, we have to use some scaffolding. So we do have a test program that has a main but doesn't do anything, right? Just to make the program complete and compilable. We're going to be using a couple of interfaces, so I've declared those, right? And so let's open up IntelliJ and try it out. So we'll copy the first one here, and we'll see how it works. So here in IntelliJ, we have the bottom part, and we'll paste in the definition of the first interface. So obviously it's complaining. The question is, what has gone wrong? So an interface has methods that are only abstract and they cannot have a body. This has to be declared. It can't be like this. So that is a problem. If you try to compile it, it's probably going to complain about the same thing, right? Cannot have a body. So that is no good. Let's try the next one. That looks a little bit better. So let's try that out. That indeed looks just fine, right? And we compile it. It doesn't have any problem, right? Let's try the next one. Right? This looks a little different from the first one in that it has this abstract here, right? So let's say, does that create any problems for us? It does not, because an interface by definition is abstract, and so you don't have to have that additional thing. But if you do it, there's really no problem. It should compile just fine. And going to the third one is this one. This makes it a little bit more complicated, but let's see what it's doing. So it's saying that it is extending mammalian and matriarchal. So these are other interfaces, right? Now it's using extends, not implements. That is okay, because this is an interface that is extending other interfaces. So it's not implementing it. It's just hierarchical. It's just extending them. So that should be fine as well, which it is. Okay. Now, lastly, we should conclude by really comparing abstract classes and interface, because they're so close to each other, right? And so this is a kind of a handy guide of how to think about it, when to use one or the other. So you use interfaces when you're defining behavioral. So if you can describe the two objects with a relationship, is kind of, right? So it's elephant is kind of mammal. Then that is an interface relationship, right? An abstract class is more of a relationship, which is a human is an organism. That's what that relationship is, right? So you're typically using adjectives in the case of interfaces, and you're typically using nouns in the case of abstract classes to define those relationships, right? All variables inside interface must be public, static, final, right? Constants and static. For abstract classes, there is no restrictions. Interfaces don't have any constructors. Abstract classes can have constructors, and a default constructor will be created if you don't provide one, and they are invoked using constructor chaining that we have learned about in previous lessons. Methods in interfaces are always transparently public abstract. You don't have to provide that, right? And abstract classes don't have any restrictions of methods being one way or the other. All right, so this has been a lesson on interfaces. Thanks.